So 3B is laws of exponents, and this should be a lot of review. You guys have been using these laws since you were in Algebra 1. So it's going to take a little time because I didn't put like all the laws on the same page. So we've got a bunch of slides that kind of go over all the laws that we use when you're working with exponents. And then we're just going to go over a few examples because I wasn't quite sure how far you went, I guess, in trig last year, though by second round I was like, oh yeah, we've done that before, but I'm still going to go over a few examples of working with these exponents. And so we will have a stat box. So go ahead and make a stat box. So we'll come back to that before we get to the examples. We are in 3B, laws of exponents. So the first two laws we're going to take a look at are with dividing and multiplying. So to divide numbers that have the same base, you keep the base and subtract the exponents. So what we see in our general example is that if I've got a to the m power over a to the nth power, those are the same bases. They both have a as the base. So to kind of simplify that, to write it as a single power, I can subtract those exponents. So I end up with a to the m minus n power. Kind of in a similar fashion, if we multiply numbers with the same bases, we do keep the base, but we add the exponents. So a to the mth power, a to the nth power, we add m plus n. These two look familiar to you? Hopefully. So next up is power to a power. So when raising a power to a power, then you keep the base and you multiply those exponents. So as we can see, we've got a to the m power, all of that raised to the nth power, so we're going to have to multiply m times n to simplify and get a new exponent. Now, if we've got different bases and we're multiplying those bases, the power of that product is the product of the powers. So what we can do is kind of split that up. So if I've got two different bases, all those parentheses raised to a power, I have to put that power on both different bases. So I kind of think about it, it's not distribution, it's not that same property, but to me it's sort of similar. That n has to go as a power to everything that's in parentheses. So every little bit that's in parentheses there. Any guesses on what the next one is? When we're dividing. So same thing if I've got a quotient where when I'm dividing something and it's in parentheses and it's all raised to a power, I have to put that power on both parts and I can split it up into a division. So if I have a divided by b all to the nth power, I can write that as a to the nth power over b to the nth power. To me, it's really similar to the previous one, is when I've got parentheses and I've got a power outside of it, that power has to go to every part, every different base, whether I've got variables for my bases or numbers for my bases, that power has to go to every single piece. You gotta remember that if I do have a power of 0, whatever it happens to be equals 1. So any non-zero number that's raised to the power of 0 is 1. Doesn't matter what it is, doesn't matter if it's numbers or letters, or sometimes when I talk to my freshmen about it, we draw crazy symbols, and we put that to the power of 0. Whatever it is, it just equals 1. And then, last but not least, are negatives. You guys remember those? Now, a lot of the time, we don't want negative exponents in our answer. Now, you do have to be really careful when you're reading directions, because sometimes it says, like, that you can. So just make sure you're reading those directions and those expectations. So, if you do have a negative and you want to get rid of it, you pretty much kind of switch it from denominator to numerator, or numerator to denominator. So for this first one, I've got a to the negative nth power. If we want to get rid of it, we've got to drop it down to the denominator. If it's in the denominator and I want to get rid of the negative, I drop it up into the numerator. Drop it up, probably sounds better. And it does go both ways. So like if you had it positive and you switch it, then it's going to go to negative. Remember that equal sign would work both ways. So there are some problems where it says simplify without any negatives, but then you have other problems that say, write in like simplest form. So kind of just pay attention to those directions to find out like if it can have negatives or not. Okay. So we're gonna hit the stat box and then go over just a few examples. I kind of struggled of what to put in here, and I don't know why that's coming in kind of crooked. But they're not in your packet. There's some logarithm stuff in your packet that's similar, but this stuff's not in your packet, even though you've been doing them for years. Do you guys have any tips to share with other people that might have trouble memorizing them? Does everyone have them memorized? Like, was this all old news, kind of? Or maybe just a little like, oh yeah, I remember that. If you are struggling and you need help, I can let you know some little things that might help, but kind of whether it's like writing down note cards or viewing them in like the lunch line, whatever you gotta do, you do need to have these rules or these laws memorized. All right, so this first example, I want you guys to write that without any negatives. So what do I do with this x if I don't want that to be a negative 4? Where does it have to go? In that denominator. So then it becomes a positive 4. So when you switch it, it becomes positive. And then what about that y? Yep, numerator, it's got to go up. So then it becomes a positive 3. So now I have that written without any negative exponents. Okay. We are going to take a look at just another kind of type of problem that you might see. So we're going to come back to that. All right, so some more examples. So these examples are going to be right as a single power of 5. So practicing this will help us in the future when we are going to solve exponential equations. We want to be able to do this, so we're just going to practice it. We're going to kind of start slow and work our way up. All right, so how would I write 25 as the power of 5? Yeah, 5 to the second power or 5 squared. Right? Yeah, okay. So then 625. Okay, I love it. That's perfect. 25 squared. I gotta do some more work though, because I want it to be a power of 5. This is great. Because I was gonna ask, like, what would you do if you didn't, like, some people know it off the top of their heads, but what would you do if you didn't? So then I can write 25 as 5 squared. And then what do I do with these two then? Power to a power rule. What was that? Multiply them. So I end up with 5 to the 4th power. So if you don't have that memorized, that's okay. We can use some other means to get there. I know some people a second over mentioned like using their calculators and dividing by 5 or keep timesing by 5, either way, to figure out how many times that would be. For this next one, let's just leave it as a fraction for a second. What do you guys think? 3,125. What do you think? That's 5 to what power? Fifth. How did you do that? What did you do? You just took a lucky guess?
I just figured 625 times 5.
Yeah, absolutely. That's exactly what you should do. So, like, if you're not sure, you can start like, 5 times 5 times 5 times 5. Well, 5 to the 4th power is 625. Let's times that by 5 again. Sure enough, 3,125. Like, the more you use them, the more you'll get used to it. But I don't necessarily think you all are going to have, like, that memorized right now. Like, yeah, the laws, the fact that you're going to multiply this you need to memorize, but some of these numbers, you've got a calculator, so you can keep playing with them until you start like learning them the more you use them. Now, this is not a power of 5, because it's 1 over 5, so I have to bring that up, and when I bring that up, it's going to become a negative 5. So now I have a single power of 5. 5 to some power, 5 to the negative fifth power. I want to just go over 2 more like this, especially because I had some people that they didn't kind of notice it when we went over them, so I want to make sure you guys pay attention to these next 2. So the first one, we're going to do 125 times 5 to the x power, and then this. Now for the first one, I noticed that part of it, this 5 to the x power is already written as a power of 5. How can I write 125 as a power of 5? Alright, 5 to the power of 3. So, like I said, the more you start using those, the more you'll remember them. If you don't have it memorized, you've got calculators to kind of play around so you can figure that out. I'm not going to give you a bad clue. I'm not going to say right as a power of 7 when it can't be. Okay, like if it says right as a power of 5, you can make it happen. Now, this is still not a single power of 5 because I've got 2 powers of 5 here. But when I'm multiplying, what do I do to my exponents? Add them up. So I write this as 5 to the 3 plus x power. There's nothing else I can really do with it. But that's where that law comes in. Right here, what I circled in black, that's the law that we have to make sure if we don't have it memorized, we work towards getting that law memorized. And that's as far as I can go on that one. Any questions there? The hint that we tell our freshmen who are learning it for the first time is that they're it's kind of in a straight line. I don't know. That's what Mr. Lima uses. Alright, so now I've got these 2 powers of 5. When I'm dividing, what do I do with my exponents? Subtract them. So I've got 5, but I'm going to have x minus the 1 minus x. So it's always the numerator minus the denominator, by the way. Don't do it the other way. That's not going to work out. So it's always the power in the numerator minus the power in the denominator. So now this all kind of depends on how comfortable you feel. I'm going to kind of change these signs almost like distributing a negative 1. So I have minus 1 and then plus a positive x. Because changing those signs, because I had to subtract them both. And then I end up with, well, x plus x is 2x minus 1 for my power there. So a lot of those main different powers or laws that we talked about showed up on these examples. What do you guys think? Do you feel okay? Ready to start it? So I just want to stress actually doing the assignment and checking your answers to make sure that if there's something that you're not doing right, you come in tomorrow and you can ask for help on it, okay? We'll have plenty of time for you guys to get started and even ask before you leave if you have a question. I know that it looks long, but again, we're practicing to make sure we're getting better at these skills that we need.